Okay, last day we stopped here. Relationship between the current flowing through a conductor and the potential difference across the conductor. Here we are going to find out the relationship between the current and potential difference. Current, which we used to measure from ampere, the symbol I, and the potential difference we are going to measure it using voltage, and the symbol is V. Okay, so we came to this activity and you learned about rheostat, and we didn't discuss about the activity, but we discussed about all the things which include in here, all the items: voltmeter, ammeter, switch, rheostat. Those are the cells which gives that potential energy, that current, initiate the current. So close the switch and quickly obtain the readings of the voltmeter and the ammeter and turn off the switch. First you have to quickly switch, close the switch and quickly obtain the readings. Okay, quickly obtain the readings of the voltmeter reading එක ගත්තා, ඊට පස්සේ ammeter reading එක ගත්තා, then turn off the switch. The reason for quickly turning off, so this one is important. The reason for quickly turning off the switch is to prevent the temperature of the nichrome coil from rising. So if you quickly turn switch on and switch off, the nichrome wire won't get too much heated. Okay, it is essential to maintain a constant temperature throughout the activity. So after some time, adjust the rheostat, close the switch and take another set of readings. Repeat the above step to take at least 5 sets of readings. After some time, adjust the rheostat, close the switch and take another set of readings. Repeat the above step to take at least 5 sets of readings. By changing the current through the circuit using the rheostat, the purpose of using rheostat is this. Using the rheostat, obtain readings for the potential difference across the nichrome coil and current, and tabulate the results in the table given below. So you have to write down the observations you get for the readings of this ammeter reading and voltmeter reading. Find the ratio of voltage current for each data set. You will observe a constant value. This is the important thing which you have to highlight. Constant value for the above ratio if the temperature of the coil was maintained at a constant value. So what you have to remember here is the temperature of the coil was maintained as a constant value. That's why we quickly switch on and quickly switch off and quickly take the readings. The relationship was first discovered by the German scientist George Simon Ohm. Who discovered this? It is George Simon Ohm. This law is known as what? Ohm's law. So we find out that if we didn't if we maintain the temperature of that nichrome coil at the same constant value, we get a constant value for the ratio of V over A. Okay, so even though we change the current going through the circuit using this rheostat, changing this rheostat, we can move this one here and there, then we can change the current flowing through the circuit, then we could obtain different voltmeter values and also same the time different ammeter values, but the ratio between them is always similar. Okay, it gives a constant value. So this one is called as Ohm's law. So who discovered this one? It's George Simon Ohm. When the temperature of a conductor remains constant, so we are going to highlight this Ohm's law. When the temperature of a conductor remains constant, the current passing through the conductor is directly proportional to the potential difference across it. So the current passing through the conductor is directly proportional to the potential difference across it. That is, at constant temperature, you remember directly proportional, we learned it in when we learned about that F equal ma equation. Directly proportional sign, it is this. So I directly proportional to V. Therefore, V over I is a constant. This constant is known as the electrical resistance of the conductor. So this constant is known as what? We call this constant as the electrical resistance of the conductor. Okay. So the unit of measuring the resistance is the ohm. That is V over I is R, where R is the resistance of the conductor. So we are getting a new symbol as R, and it is the resistance of the conductor. The unit of measuring the resistance is the ohm. If a current of an ampere 1A passes through a conductor for potential difference of 1 volt across it, then its resistance is defined to be 1 ohm. Ohm's law can be expressed in the form of the equation as V equal IR, where V is the potential difference, I is the current, and R is the resistor. The instrument used to measure the resistance is known as what? Ohm meter. Okay, if a graph is plotted using your data with the voltage difference in the y-axis and the current in x-axis, you will obtain this kind of graph. Okay, I'll continue this later. Thank you.